Hello and welcome to Old Dominion University's REYES Science Panel, Discover Science. Today's topic will cover why study science in the age of COVID. Science has been at the forefront of news headlines on a daily basis. There are ODU alumni who are working the front lines of the global pandemic, COVID-19. But they started their journey at Old Dominion University. And to all of the frontline workers, we would like to say thank you. Expert scientists from Old Dominion University's College of Sciences will share their insights into this vital field. Today, we'll explore the various science disciplines at ODU that range from ocean and earth sciences, biological sciences, physics, psychology, mathematics and statistics, and chemistry and biochemistry. At this time, I would ask that each of the panelists introduce themselves. We'll start with Dr. Drew Chappell.
Hi, my name is Dr. Drew Chappell. I'm an associate professor in ocean, earth, and atmospheric sciences, and also the associate chair of the department.
Thank you. Dr. Michelle Kelly, next.
Hi, I'm Dr. Michelle Kelly, and I'm chair and professor in the Department of Psychology.
Dr. John Adam.
Hello, my name is John Adam, and I'm a professor in the Department of Mathematics and Statistics and joined the department an exceedingly long time ago. I will briefly say that I teach classes in mathematical biology at several different levels, so I'm excited to share some of what we're doing with you.
Thank you. Dr. Deborah Waller. Dr. Deborah Waller.
I had to unmute myself, sorry. Hi, I'm Deborah Waller, and I'm an associate professor in the Department of Biological Sciences, and I've been here 30 years, so maybe John's been here longer.
Dr. Charles Sekinick.
Charles Sekinick, professor in the Department of Physics, and I'm chair of the department. And my research spans two different disciplines now. One is atomic physics and laser science, and I've used some of the knowledge that I've gained from doing that research to branch into oceanography and remote sensing and oceanography. Thank you.
Thank you for introducing yourselves. To our audience, as you can see, ODU has a wide range of sciences where students and faculty heavily focus on research in the class, in the lab, in the field, and professionally. Now, let's discover monarch sciences. Each panelist will talk about why you, the participants, should pursue the sciences during the age of COVID. Also, feel free to start sending your questions via chat, and once the panelists have given their overview, we will then make time for your questions and answers at the end. We'll start first with Dr. Chappell. What can you tell our audience about the world of ocean and earth sciences? Let's have her unmute.
All right, I managed to share my screen. I forgot to unmute. So first, I want to thank everyone who's showed up to this panel. Science is all over the news these days, and it's focused a lot on COVID-19, but what's happening in the world and how the world is responding and how that's impacting the environment is still very important and still something that is very useful to continue studying, even in this age of a pandemic. And one of the things that I really love about our program at ODU is that it is very interdisciplinary and it's very quantitative, and the skills that students can gain by studying any science today will help them be better informed in terms of their ability to critically read the news and know what's happening in the world around them and be able to help their families in understanding what's going on in the sciences. So we have, at the undergraduate level, we have a Bachelor's of Science degree with 7 different various tracks that we guide students through courses appropriate for those disciplines. We have a minor program and some certificates as well. All of the concentrations that we have in our department are designed to basically help students prepare for a range of different professional goals in the sciences, engineering, and business, including going to graduate school, working in oceanography and quantitative disciplines, geology, working towards a professional geologist certification, working in and being employed in industry, in with non-governmental organizations, with local, state, and federal government agencies, and consulting. And then we additionally have a special track that is jointly done with education that prepares students to be teaching earth science in secondary schools. We also have a variety of graduate programs. We have a master's degree in ocean and earth sciences and a PhD in oceanography, with a variety of different research emphases that are associated with the research that are in our the research that our various faculty do in a wide range of oceanography and geoscience fields. And finally, I just wanted to finish with what you can do with a master's degree if you decide to go on to graduate school, in addition to the various paths that our undergraduates take. A lot of our master's students have obtained jobs in the environmental fields, working as advanced technicians, in policy analysts in federal, state, and local agencies, or for environmental consulting firms, and as well as working in university research labs. And then our PhD students, those graduates have gone on to many faculty positions at universities and colleges, as well as become federal and state agency scientists. And additionally, some have chosen to take a track that moves more towards business and consulting. And so I just wanted to finish with that, and then also give a shout out to 2 possible online courses that are going to be offered this fall to more than just the ODU students. We have an online course that looks at the land, estuarine, coastal, ocean continuum that is open to both Virginia students, outside Virginia students in the US, and outside US students. And our environmental geology course, which is open to Virginia and US residents outside of Virginia as well. So thank you, and I'll stop sharing my screen.
Thank you, Dr. Chappell. Moving on to psychology, Dr. Kelly, why should students pursue psychology?
Hi, I'm going to talk a little bit about, psychology and just why, you might be interested in studying psychology as a science. And then I'm going to talk a little bit about how psychology and COVID-19 really intersect. So if you've ever wondered why you did something or why somebody else did something, psychology will really help you understand yourself and other people better. As Dr. Chappell mentioned, we really do learn in psychology how to do research, which just makes you a much better understand and a better consumer, I suppose, of science. You learn really to improve your critical thinking, conceptual reasoning, and communication skills. You will really appreciate human development more. As we say, we are a womb to tomb science. You will better understand mental illness, and there is literally a specialty for every passion you might have. So I know some of you are familiar with clinical psychology or health psychology, but you may not have heard of organizational and personnel psychology. These are folks that work in businesses and help them run more effectively. social psychology, forensic psychology, developmental psychology, etc. And I think psychology is also sort of a perfect companion to a lot of other disciplines. So let's suppose you want to go into business, but you really need to understand, your consumer, their motivations, what it is they're looking for, how to really appeal to them. Okay. So psychology can certainly help with that. And how is psychology really sort of right in the center, I suppose, of the COVID-19 epidemic? It's really impacted all of us, our lives, just in so many different ways that are part of psychology. And in fact, I've actually heard it called COVID-19, called the biggest psychological experiment ever. At one point, over half the world was in lockdown. So I probably don't have to tell many of you that stress, coping, anxiety, depressive symptoms, irritability, all of these things have been impacted and have been increased. But I guess the bigger questions that we really don't know the answers to, that are really out there waiting to be studied, are what is the impact that lockdown or social isolation will have, not only short term but long term. And what about some of you out there that maybe before COVID-19 you spent tons of time with your friends, and now all of a sudden you're spending all your time with your family? What impact will that have? Or what about if you were planning on leaving home and now maybe that's been delayed? I mean, what is the short term and long term impact of that? Some of the other things that have been impacted by COVID, so these secondary impacts, are social issues. Things like child abuse and domestic violence are up. Filing for divorce has increased. So these are the kinds of things that psychologists study, that we try to understand. We try to develop interventions to more effectively help people cope with these kinds of things. Health behavior. I know probably all of you have been at the grocery store or someplace and you've noticed that some people adhere to safety guidelines and they're wearing a mask and so forth, and other people don't. Have you ever wondered about those people that don't? Like, what is going on with them? And what about your own attitudes towards people that are not complying with these safety hazards? So these are going to have a long-term impact on people. Health disparities. We know that Black people are dying of COVID virus much higher rates than non-Blacks. So that just, I think, increases our awareness and understanding that, there are major health disparities in this country that need to be addressed. Mental health and economics. COVID certainly has an impact on those that have been impacted economically, that have lost their jobs and so forth. And I think to some extent, COVID may have even been changing priorities for some of us. I also think there's some of the things we've talked about are old issues, but then there are a lot of new things that we need to study, that, we need, junior new investigators to really develop these areas of research, such as something that I've studied for a while is moral injury. And this is the idea that I've studied in a military veteran. So these are veterans who go to war, and maybe in some cases they do something that unintentionally sort of violates their own moral code, if you will. So your job maybe as a soldier was to go and to kill combatants, but you unintentionally harmed maybe a civilian, okay? Well, this is known as, when you breach, if that makes sense, your moral values in that way, this is known as moral injury. And sometimes people really have these strong moral emotions. But one of the things we've noticed with COVID-19 is that healthcare providers are frequently in these very difficult situations where they are violating their own moral codes. So maybe they don't have enough ventilators for all the patients that need them. Okay, so they have to make very difficult decisions. So all of a sudden, there's this whole new field opening up to look at these kinds of things, and healthcare providers, those on the front lines. So what psychologists can do is really help understand sort of the many ways that COVID impacts us. And, there have been so many things that have come about. In fact, telehealth right now is just huge. So these are kinds of things that are going to be, increasingly important and need to be addressed. Just very, very quickly, in a minute or less, I'm not going to go over all of this, but we offer undergraduates here at ODU lots of things. So we have certainly research experiences, study abroad, honors, leadership programs, entrepreneurial programs, clubs, etc. So just a few of the things, and just a highlight of a couple of courses, and then I'll turn it back over. But abnormal psychology, so studies sort of etiology or the cause, risks for, and course and treatment of things that are often known as mental illness. Psychology of the zombie apocalypse. So this is actually a perfect time for a course like this. So that really does look at traumas and catastrophes and so forth, and people who's at risk and how to respond and how to cope and so forth. Psychocriminal behavior, which really looks at violent and nonviolent crimes, sexual offenses, except treatment, etc. And physiological psychology, so study of biological basis of behavior, including motivation, learning, mental illness, memory, etc. And finally, I'll end on a positive note, which is we have a course called Positive Psychology. And this course really focuses on factors that contribute to happiness and a fulfilling life. And you do a lot of hands-on stuff with assessments and experiential exercises, so hands-on exercises to help you kind of understand and how to cultivate a meaningful life.
Thank you.
Thank you.
Thank you so much, Dr. Kelly. Moving on to mathematics and statistics. Dr. Adam, why should one study math and stat right now?
Well, first of all, one of the things as an applied mathematician that I love to do is mathematical modeling. And this is something that is so powerful in many respects. Any kind of problem can be formulated in simplified terms, often to try and find out the underlying mathematical structure. Now, what I'm going to do in a moment is share a screen from a talk that I attended, a webinar I attended. But I will say, first of all, that Ms. Whitfield has put a shot collar on me. So if I go over my 4 minutes, all she has to do is press a button and I will stop. I'm very tempted to hijack the whole meeting because the equations are so interesting. We may not get there, but I'm going to try. So if I share this screen, hopefully you will see, and I can't see it actually, but which is a problem. Okay. Well, can anybody see the screen there?
Yes, we can see it.
Kevin, can you see it? Okay, I don't know what I'm scrolling through because I don't have it here on my screen. Anyway, since I can't see it, that's going to be a problem. Well, let me just talk about it. Basically, this was a talk given by Professor Nina Pfefferman at the University of Tennessee.
John,
and
sorry.
She gave me permission to use some material from her slides. In this talk, she spoke about how to set up the equations for what's called an SIR model, which is...
Sorry. Can you hit stop?
Which is essentially modeling the number of susceptibles, the number of infectives, and the number of recovereds. We catch a disease by coming into contact, if we're susceptible, with people who are infectious, and their germs spread to us and we get infected, and at that point we can recover or die, and hopefully it's the former. But in setting up the equations for this kind of model, this mathematical model, we can actually gain some insight into what it means, what the R0 number means, which is something you hear about on the news, the rate at which the disease can spread. And basically, the mathematical model can give us some sense of how we can perhaps reduce that R number in order to limit the growth of the infections. And again, this is something that can be developed to various levels of sophistication, but essentially it's basic algebra and rates of change. So there's a bit of calculus involved and there's a bit of interpretation, because a mathematical model is no good unless you can relate it to data, to observations, to clinical studies. And so it combines the best of mathematics in a sense with the best of its applications. So I will stop here. I apologize for not able to. Yes.
Sorry, John, can you hear us?
I can.
Good. So you're not sharing, I think what you think you're sharing a web link for Cisco WebEx. Do you have your slides, or do we have your slides? Because we can share them for you if you prefer.
Sharing screen one. By the way, not all mathematicians are incompetent, so please don't take that. Let's see. Oh, okay. Well, that's what I wanted to talk about. Right. So, Professor,
I think you got it. You're good.
Okay, I won't go over all this again, but basically summarizes what mathematical modelers do. Take a real world problem, you try and simplify it, you distill it to its simplest mathematical form, and then you try and see what the predictions will be from that. So here we're talking about healthy, susceptible people, catch infections from sick, infectious people, and they come into contact with them, and the germs are transmitted. So there's two things here. We want to reduce contact by social distancing. We also want to wash our hands frequently to avoid minimize the transmission of germs. And so the rate at which susceptible people become infected is called rate 1, and we'll go on to the rate at which, since we're not going to allow people to die, the rate at which infected people recover. So that's rate 2. And what does is to talk about these SIR models, so she can set up equations for the number of susceptibles tomorrow in terms of the susceptibles today, and the number of infectious people tomorrow. And so she goes through and talks about why outbreaks end, and that's basically because the number of infectious people increases as the number of susceptible people go down, and eventually, when there are fewer susceptible people, the number of infectives go down because there are fewer people to infect. And so essentially what happens is you end up, why you actually took algebra, that you can get the infection is increasing when this inequality is satisfied, and that also implies that the number of susceptibles can only decrease. So the infectious curve goes up and then goes down over time, and from that we can get this R0 rate, namely the first rate times the number of susceptibles today divided by the second rate will exceed, if it exceeds 1, then the outbreak will increase. And here are some R0 values for some well-known diseases. Measles is quite high. Now the COVID-19 is somewhere in this range. I think there's more data now which suggests it's closer to about 2.5. Influenza can be quite small. Obviously, what you want to do is to minimize this R0. Okay, I will stop there. I will stop there. Thank you.
Awesome. Fascinating work to present and more to get to. So Dr. Waller, why should our audience members consider biological sciences?
There we go. First of all, so whether or not we were in the middle of a pandemic, we would want to study biology because it is fascinating. But it has all to do with COVID-19 because it is a virus and it's a unique virus, and there's so much we studying it and trying to understand its dynamics and what it's going to do to us, essentially. We're also looking at the origin. So most of us think that the origin of the virus came from bats, but what the route was, we still need to trace that, but biology can help us do that. We also want to know why people are susceptible. So I know this is important to other fields also, but in biology, why are different age groups have different susceptibilities? For example, I grew up when polio was a scourge, and it was little children who were at risk. And now we're worried primarily about older people, although more information is coming in that younger people can be highly at risk. So there's just a lot to work out. And again, biology is going to help us do that. We also need to know more about our immune systems because immunology is a huge subject, and there's so much to learn, and we're learning something new every day. So it's a fascinating area, but it's very relevant to the pandemic. So why are different people susceptible? We've already talked about that. How do their immune systems differ? What causes different groups of people to be more or less susceptible? And how long, first of all, we don't know with most viruses, if you contract it, then you are immune to getting it for a short period of time or sometimes a long period of time. We don't know that for this virus yet, so this needs to be studied. So there's just so much to learn about what is coming up with immunity and virology. And then, of course, everybody's racing to get a vaccine started. And there are many different countries that are working on this. And it's very tricky, and we can't really predict when we will produce an effective vaccine. So we actually have an ODU, we have a researcher who studies vaccine failure, what causes vaccines to fail. And that's what they're finding about some of these vaccines that are being produced, they're not working. So why? That's something a biologist would study. Then, of course, we're looking at therapies and finding old medicines that work for different diseases might be effective with the COVID-19, and we're trying to figure out which ones will and which ones are going to be important. And then also related to the disease, toilet paper is in the news a lot. So toilet paper is all about biology and which trees are best to produce it and how fast do they grow and how is it produced. This is all related to what we know about the virus now and what we need to continue as a society. So those are some of the biomedical reasons that we need to study virology and the immune system. But of course, we've kind of put aside our concern for the moment about conservation biology and climate change, which is really the issue of our age. We really need to address it. And in order to address it, we need to study biology. So in the oceans, coral bleaching is a big issue related to climate change. Vector-borne diseases, mosquitoes and ticks transmitting diseases, how will they respond to climate change? We are studying that. Pollination biology, where does our food come from? What is happening with bees with colony collapse disease? People are studying that at ODU. People are studying polar bear physiology, looking at the impacts of climate change on polar bears. And again, back to pine trees, with producing toilet paper, we have researchers at ODU studying the longleaf pine, which has been reduced to 3% of its original range when we first came to this country as Europeans. And the colonists would not have survived. Our country would not be built without longleaf pine. We depended on it for everything. And so studying the biology of longleaf pine is really crucial to continuing this kind of research and understanding where we come from. So also, again, back to the oceans, fish overharvesting, that's going to have major repercussions. There are just so many things to study in biology. It's all fascinating. We learn something every day. So thank you, and I hope you will study biology.
Awesome. We want to get to physics. Dr. Sekenik, would you please talk about where physics fits in nowadays? Is he still with us? Dr. Sekenik, are you still with us?
Yes, can you hear me?
Yes, go ahead. Now we can.
You can hear me now. Okay, great. Yeah. So I'm going to touch on some of the same themes as my colleagues did. It's important to remember that nowadays science in general is much more interdisciplinary than it was even 5 years ago, certainly 10 years ago and 20 years ago. And so more and more there's overlap between different areas. So you can study physics and you can study biology and you can study biophysics. A lot of disciplines in engineering overlap with physics. And this is becoming true in most areas. So if you study physics or you study another discipline, you should always keep in mind that you're not locked into just that one discipline. You have an opportunity to branch out. Whatever major you follow, it's not only preparing you with the specifics, the information about that area, whether it be oceanography or chemistry or physics or math, but you're also learning a lot of other important skills that have been touched upon, including critical thinking, being able to solve problems, being able to apply what you've learned to new problems, not just to work on problems that have already been solved and make incremental improvements, but to try to solve all new problems. And in physics, physics I think is an excellent field for building critical thinking skills. So that's one thing that physicists are quite good at. Of course, they will specialize. If you go to graduate school, you'll specialize in a certain area. As an undergraduate, you get a little bit more of a broad preparation. But one thing that all physicists have in common is we really hone critical thinking skills. We don't want people to memorize things. We don't want people to necessarily just know things. Of course, you do have to know facts and material, but we want students to be able to assimilate what they learn in a way that allows them to tackle problems that they've never seen before. And physics is, I think, really good at that. And as we face challenges today, including the COVID epidemic, but all sorts of other challenges that we're facing on the planet with sustainability, issues in our economy, issues in our infrastructure, and so forth, I don't think there's an major issue that we're facing that doesn't have a physics component to it. Not exclusively a physics component, but some sort of physics component. And in the physics department, we have a number of areas which we're very strong in, including both theory and experiment. Some students, when we say experiment, that usually means working with your hands, working in a lab, working with equipment. Some people really enjoy working that way, and some students, they prefer to do theoretical calculations. So they're more interested in theoretical physics, which is somewhat mathematical. There's a lot of overlap with mathematics. One thing that's really important, I want to stress to all the students, is whatever discipline that you go into, you should pursue it because you love it. You may be very good at something, but just because you're good at it is not a reason to make a career out of it. You want to have a career of doing something that you really love. And people who do physics, I think, really love physics. People who do biology really love biology. It doesn't mean that the biologist couldn't do physics or the physicist couldn't do biology, but people choose disciplines that really appeal to them. And that's where you're going to be most successful, not only at something that you're good at, but something that you love doing. And so in physics, you may get, as an undergraduate, a very broad preparation. You'll get hands-on training. You'll learn how to work with electronic circuits, and you'll learn how to do computer programming, and you'll learn how to solve problems in quantum mechanics and electricity and magnetism. And you'll take advanced courses. You'll take a lot of math courses as well. And some of our students continue on in physics. They might go to graduate school in physics, or they might go into industry, get an industry job where they apply their physics. But not everybody continues in a physics direction. We've had students who went to medical school. We've had physics who went on to law school. We've had physics students who went on to Wall Street. They went into finance. So we've had students who went into the patent office. So I think that, it's true of other areas as well, but you're getting a broad-based preparation, and that you can apply that in a large number of areas. Specifically, and I'll just finish up one more minute. I just want to say, in the physics department, we work in a number of areas, including nuclear physics, both experiment and theory, atomic, molecular, and optical physics. We're growing in condensed matter physics. We're going to be starting an undergraduate program in astrophysics. And I just want to point out that we're next to Jefferson Lab. So Jefferson Lab is perhaps the premier nuclear physics facility in the world. And you may have heard of Fermilab in Brookhaven and SLAC out at Stanford, and also Jefferson Lab. So a good fraction of our department is involved in one way or another working with Jefferson Lab. And so there are a lot of opportunities for students, both at the undergraduate and graduate level, to work at Jefferson Lab. Thank you.
Thank you. We do have one additional department to focus on, and if she could briefly give us a 2-minute overview so we can get to the questions. Dr. McCoy from Chemistry and Biochemistry.
Hi there. So I would just like to echo what my colleagues again have said with Dr. Stukenik and Dr. Waller in physics and biology is that, you know, everything is interdisciplinary, and that with chemistry and what's going on currently going along with biology, it gives you an opportunity to look at synthesis of drugs to use to treat or possibly treat the COVID epidemic. And then also with chemistry, there's been so much talk about how do we make hand sanitizers. So with looking into chemistry, you can look at what is the chemical makeup? What are they putting into these hand sanitizers that everybody is trying to make, either on the side, or if you look at many of your brewing companies are trying to make hand sanitizers. So moving into the chemistry field gives you an opportunity to look at those components in the chemistry of treatment, as well as how are we helping to keep our environment clean or keep ourselves clean. So and also going along with Dr. Wallach, and she was talking about there's so much relationship between chemistry and biology, even if you're looking at treatment. Why are some people more predisposed to having symptoms versus not? So there's a kind of genetics that's associated with that. And some people may not know this, but there's biology and chemistry, genetics all go together. So whether or not you choose biology or you choose chemistry, there's always going to be some cross in between those two areas. And then again, on a sidebar, as far as what Dr. Stukenik was saying about how everyone is, you should always think about what you like and what you love. You should always try to choose something that you like, and it gives you an opportunity to grow from that particular area. For example, I started out in pharmacy, and then grew with that to move into biology, and now here I am in chemistry. So there's so much crossover that it gives you a chance to grow in the area that you choose. And in chemistry and in all the disciplines, you're always going to get some kind of experiential learning, that you'll have that ability to learn about what instruments can I learn how to use, what glassware, how can I analyze different components or different areas of these hand sanitizers.
Thank you. All right, we got all 6 departments in. So we have lots of great questions from our audience, and we want to start with Zoe from Glasgow, Scotland. She asked a 3-part question, and 2 of her questions have kind of been answered, so I'm going to skip to the last part. She asked, is there any advice you would give to someone who is just starting their career in science? Who would like to take that question?
Well, I'll take it. This is Charles. Should I go?
Go ahead, Charles.
Yeah, so that's a great question. I think that you should start by pursuing what you think you're interested in. And sometimes people will pick an area to study, but they don't know a lot about it, but they think they're interested in it. So you should start by, but then they may learn that they're interested in something else. So if you absolutely know what you want to do, then maybe you can focus a little bit on that area. But even there, you may find that there's an area that you like more. So if you're just starting out, take a few classes in different areas. So you could take a physics class. You know, most science majors, you're going to take a math class, probably take a physics class, maybe a chemistry class, maybe computer science. Your freshman year doesn't necessarily lock you into the major. So take classes in a number of different areas of science and see which one you really love, and then pursue that one.
Dr. Waller, did you want to answer as well?
Yes, I was just going to say that I'm an entomologist, and many students take my class because they have to, and to fulfill requirements, but after they take it, they love it. And most entomologists started out by accident. They didn't go into entomology. They had to take a course. They fell in love with it. So take courses that you wouldn't normally take.
Thank you both. Oh, I'm
May I
sorry.
just-
Someone else want to answer?
Yeah, I would just say that for the benefit of the young lady in Glasgow, which is how you pronounce it, the British system is very different, or was, so I'm not sure there's the flexibility to take classes like that. I think you have to choose your major pretty early, but maybe things have changed because I was there a long time ago. Thank you.
Thank you for weighing in. Lena.
Could I maybe
Go ahead.
could I maybe add something? I'm not part of the panel, but I'll add, even though that Zoe may not be able to take entomology in college or in school, she can take an entomology activity course with Debbie Waller in July 1st. So
Thank you.
here in Regis. So anyways, just wanted to plug
I'd
that.
also like to add that entomology is the study of insects. So I'm sure there are a few callers that don't know what that is. Okay.
Thank you. Thank you for clarifying. Next question, Lena from Marysville, Washington asks, does ODU offer classes in the medical fields? I'll let Dr. McCoy start with that one.
And Dr. Waller could probably add on to this, but so the medical schools here, at least in the United States, you are required to take the full year of a freshman level chemistry and a freshman level biology course. So in that respect, yes, we offer many of those courses that you need to apply to medical school across both the biology and the chemistry departments. And I know that the biology department at ODU offers a probably one of a kind cadaver dissection class as an undergraduate that you would not get until you actually enter into medical school.
Dr. Waller, would you like to add in?
Yes, that's true. People love the cadaver course, but we have many biomedical courses on cancer biology, immunology, all aspects of virology, all aspects of the medical field.
Thank you. All right, next question is Diego from Livermore, California. How do you pick which science you should get a degree in, especially if you are interested in almost all of them? Who wants to tackle that one?
I'll jump in. I think that an answer to that would be, I think Charles Zukenek has done that pretty well. And on your way to most science degrees, you will have to take a lot of different science courses. So, I mean, in oceanography and earth sciences, we have to, a year of biology, chemistry, physics. So along the way, you'll get a taste of which of the disciplines really speaks to you more. But a lot of science is becoming more and more interdisciplinary. There's a lot of interaction between chemistry and biology. There's interactions between oceanography and almost every single science discipline. And so I think that the best advice I would give to someone who's starting out and trying to decide is to take those intercourses and start thinking about which one really felt the best to you, but don't be afraid to get a degree in one of the sciences and move on slightly tangentially. So my undergrad degree is in biology, my PhD is in chemical oceanography. So I didn't miss out by having a different undergrad degree than what my graduate degree is in. It just helped me be more interdisciplinary. And so take advantage of opportunities as they come along, and don't be afraid to change your course, because there really isn't a direct path to any specific job.
Thank you. Thank you, Dr. Chappell. We have a question from Kernia from St. Lucia. She says, I would like to become a veterinarian. Would ODU be a great choice of schooling? And if yes, what is required to apply to attend ODU?
Well, yes, we do have a pre-vet program, and we have many courses that are relevant to veterinary school. So I teach animal behavior, and many of my students take animal behavior on their way to becoming vets, because that's very important. So we have a good program for students interested in becoming veterinarians.
Thank you. We have a audience member sending us a question from India. She asked, does ODU invite students from India for summer exchange program or summer internships? And also, would professors be open to questions regarding their research and papers they have published? Good question. Two good questions.
We have a specific program with exchange with India, as far as I know, but we do have exchange students from all countries coming, and we send students to other countries all the time too. So it's very easy to form these connections.
Also, we will have a panel later on about online courses where students can take classes from anywhere around the world on a variety of different topics. So there's not quite, I don't know if there's any exchange programs with India, but there is a way for students from India to take classes at ODU remotely.
Thank you.
May I just add that, like many of my colleagues, I'm sure, I get emails, sort of random emails from people all over the world wanting to know questions about papers I've published or articles. And very often it becomes a fascinating back and forth. And it's very nice to get emails from real people.
Would anyone else like to talk about their research at this time? Okay, we're gonna move on to, we have another question from Patricia in Virginia and asks, she says, I love psychology. So this is to you, Dr. Kelly. What is the best psychology field to be in?
That's a toughie, okay? There's a lot of opportunity right now for really almost anything. So a lot of students are interested in clinical psychology, and you can certainly, get your degree in clinical psychology and then move on into private practice, medical school, academics. We also have a lot of students, and we have a doctoral program in organizational psychology here. And if you're interested in working in businesses, the field of industrial organizational psychology has just blossomed, and our students are scooped up so fast. The challenge we have is keeping them and getting them to finish before they get good jobs. And finally, I'll just kind of mention that another area that we have a doctoral program in is human factors psychology, and that really looks at the sort of, it's almost engineering. So sort of the human component to engineering and developing designs and so forth. So I really, all of them are really, psychology is blossoming, and I don't think you can go wrong with nearly any field of psychology. And you can email me if you'd like, and I'll follow up with you.
Thank you so much. We have two more questions I think we can squeeze in. We have Karan from Mumbai, India. I always feel like learning more about my subjects and do a master's and a PhD, but then I also want to get into the industry. How does one decide when to take the leap?
I can take that. Can you hear me, Tiffany?
Go ahead, please.
Yeah. So some people feel that they have to make that decision when they start, and actually you don't. If you come as an undergraduate, whatever you study, you're studying for 4 years. You might even be in a program where it's a 4 or a 5-year program where you choose to do the master's, for example, along with your bachelor's at ODU. But the decision that you're talking about does not have to be made at the beginning of your studies. You can wait until you're about to graduate, and you can even apply to graduate school and apply to jobs and see what graduate schools are appealing to you, see what jobs are appealing to you, and then you can make an informed decision. But students sometimes are afraid they have to decide that at the beginning, and you don't. You can decide that when it's ready to make that decision.
Thank you. And I think we have time for one last question. Daniela from Puerto Rico says, hello, I know of people that have skipped the master's and have directly done a PhD. Would you recommend that?
I'll chime in. I think it depends on your field, but it's and it sort of depends on how much you know about what you want to do. So to do a PhD, you really need to have some idea of what your research is going to be quite self-directed in most fields in getting a PhD. And so some students do well by starting with a master's, and then if they're growing to the point that they have more questions and can sort of expand that, then they can transition into a PhD. I took time off in between undergrad and grad school and worked, and then went into a PhD program without doing a master's. And that worked for me. But again, this is one of those things that you don't have to make that decision on the day that you're starting undergrad, the day that you're graduating, even the day that you start grad school, because in a lot of cases you can change your path. And our department, you can transition from the master's program to a PhD program or vice versa, without a lot of extra challenges. So I think it's important to have the understanding of what you feel is your best path, and don't be afraid to change courses again along the way.
Thank you. Thank you to all of our panelists today. We really appreciate you putting ODU on the map and exposing it for what it really is as a research facility and university. And to those that we did not get to answer your questions to, we will do our best to answer them online. Thank you again, and we appreciate you for taking your time to discover sciences on today at Old Dominion University.